Deflated.
Okay.
Santa.
Let us begin. So, today we're going to be in chapter 2 and then section 3. So we're going to be working with quick graphs of linear equations.
Yay.
So does anybody remember the types of linear equations that we've been dealing with so far?
75.
There have been different forms.
Slope-intercept form.
Slope-intercept form is one of them, yes. So you have y equals mx plus b, and that's slope-intercept.
Wait.
I'm just gonna go with it.
Okay. Slope-intercept. So, any other equations that you guys remember?
No. What was the one?
Standard form.
Standard form. So you have ax
Oh, and point slope form, right?
and point slope. Very good.
Yay.
Equals c.
I have that written down.
That is the standard form. And y minus y1 equals m times x minus x1. And that's point slope. I did math in my sleep again last night. It's so annoying.
What?
I do so much math that I dream math problems. And I get them correct.
I
you
see
ever get
Russian
them
in my sleep.
No. I mean, I might the dream might shift. And all of a sudden, instead of doing a math problem, what was I doing last night? Avoiding a spider in the corner of my sister's room in the house we
That's like a
lived in
nightmare.
until I was 16. And we were preparing it for realtors to come.
Oh, wow.
And I wanted to jump on the trampoline and I had paid for it, but I wasn't allowed to. Yes.
Wow, that's
That was what I remember.
completely unfair.
Not my dream. I know, right?
What?
I was like, trampoline! Okay, so here we go with the... oh, wait, first, really important. Are we going to order food?
Yes.
Yes.
Because we should do that right now.
I'm hungry.
Let's pause.
Can I?
Oh my gosh. No,
21 to
Back to
30
that.
minutes? What?
What?
Well, we still have almost a full hour left in class, so we'll be okay.
I'm hungry now.
I'm
go.
hungry now too. Well, let's focus
I
on
have more
that.
classes. I want pizza.
Okay.
So we put that on a shirt.
It sounds like something in Forever 21.
Yeah.
Forever
Okay,
21 is a
so-
terrible place
It
full
really
of broken
is.
dreams.
Finishing up with...
Oh.
So finishing
You
up
used to
with
be owned by
types of
Christian girls.
equations.
My uncle actually knows
Okay.
that. I'm shopping at Costco.
People.
He's a designer for each.
Hey.
Hey.
Sorry.
Cool. So moving on. So if you're given a 2 points, 3, 5, and -2, 15. Does everybody know how to take these 2 points and write the equation out of them and convert from one equation to another? Samantha's nodding. Tori?
I need warm up.
I need warm up too.
Okay.
I think I could do it.
I'm just confused on how you would find like the y-intercept.
Okay.
What is it? It's like
think
not
it's-
in your active memory, right? How does that work?
I don't know.
It's in like the backbone of your brain.
The backbone.
backbone.
Like,
Backbone.
you already know it, but it's not in your active.
All right, so
Yeah,
what
that's
you need
fine.
to do is identify, you just need to pick. 1 point is 0.1, and 1 point is 0.2.
I know one.
So then, you need to find the slope, which is defined as the change in y over the change in x, or y2 minus y1 over x2 minus x1.
I can't see anything.
So it's like the one you did on the board last week, where as long as like they match up.
It's identical to the one
Right.
I did board last week.
So
Yeah.
how do you figure out which one is x1, y1?
You could just pick, because it doesn't matter.
Okay.
If they're both on the same line, it doesn't matter which one you do first and which one you do second, as long as you're consistent.
Okay.
So we're going to have y2 be 15 minus 5 over -2 minus 3. Because x2, x1, y2, y1. Woohoo!
Yay!
So 10 over -5. Our slope is -2. From here, we talked about you can put them into either one of these equations. If you put them into y equals mx plus b, you're going to be using one of these points for your y and your x values and solving for b, because this is m. Or you can plug it directly into here, using one of these points as x1, y1, and then the slope is the m, and then just solving it from there. So everybody's good?
Mhm.
Do you remember how to convert to standard form?
You can just plug in the numbers, basically, right?
Well, you should already have your all other equations set up when you're converting it to standard form from there.
Okay.
There's not really plugging in, just rearranging.
Okay.
so-
So we should already know what B is then.
So A and B, see how these ones are capitalized here? That means that they're different from like this B value here. So they're signifying totally different things. So if we have this line, or these 2 points on the line, we're going to plug them into y minus, so let's do 15, equals m, which is -2, times x minus, now I need to use the x coordinate from this point, so minus -2, which becomes +2. So here's this is point slope form right here. So if in your homework, if you're asked to put it in point slope form, you stop. You don't do any more math, you're done. So then you get y minus 15 equals -2x minus 4, because we're distributing this -2. Moving this over, and by adding it to both sides, you get y equals -2x plus 11, because it was plus 15 to get it over here, minus 4 is 11. To get it to standard form, because now we've seen it in point slope form, this is slope intercept form, you're going to move this over here by adding it, so then you get 2x plus y equals 11.
Like, how does standard form look again? Like, just in general? Oh,
Okay.
sorry.
No, that's all right.
So wait, so B is just not there anymore.
Right.
Okay.
It's only B.
And it's still in standard form.
Right. When you put it in this form, it becomes B, the y-intercept. Because if we plugged in 0 for x, this would be gone. Because 2 times 0 is 0. So y equals 11. So when x is 0, y is 11. That's the y-intercept. Does that make sense?
I think so.
Okay.
Right.
So. Woohoo! Erasing everything. I probably. Who thinks that I should have
even try.
asked permission before I ordered pizza?
Don't.
No.
No, because it's easier to ask for forgiveness than permission.
I was literally
Yes.
gonna say
Well,
that.
actually,
That's not like
yeah.
Probably not a life lesson I should be teaching.
Well, our what's her name, Mrs. Lucas. She's gonna bring baklava to our history class sometime.
Well,
soon.
I think it's okay.
But
She's
that has
going to.
nothing
to
Kitchen
do-
is right over there, so it's not like we're like bringing it upstairs.
I just
It's like-
don't know if they're going to be all like,
friends with her.
you
She
can't do
knows
that
themselves.
in front of other people.
Just, like, calculate
But
the
we're
circumference
in
of
a
the pizza or
closet.
something.
Yeah,
we just go-
that's what we're doing.
Yeah.
That's what we're doing. We're building equations. And pizza is perfect because I can do fractions out of that because there are 8
Exactly.
slices in every pizza.
Yeah.
There you go.
Yep. Okay.
Mr. Merritt
It's
was
just
the one who
like
came
my
up with
math.
I'm
math
so glad that
tools.
he's gone.
Circumference,
I didn't like
exactly.
this.
So.
And one.
Okay.
It's, like, it's so efficient. Why not?
And then
What?
after we use math with the pizza, we have to clean it up.
Pizza?
Then we
Yeah.
learn about biology.
There
like
you
I
go.
said, like,
Yeah.
in school.
You
Okay,
can't let pizza go to waste.
Yeah.
All right. Hunger Games time. Who wants to volunteer?
Nope.
Nobody.
I hate that book. I
What?
finished it yesterday. It's not like
I never
I watched
said
the
that.
movie first, and then I read the
Yes,
book.
Samantha.
Okay.
Okay.
Just find.
You're gonna graph these 2 lines with whatever color you want to. I got more colors. They arrived. They're 2 separate lines.
Right here. Oh.
Yeah.
Yeah.
Okay. Um.
Perfect. That looks beautiful.
That is so straight.
That's really straight.
That's
Thank
so-
you. I perform well under pressure, I guess. That one
Not
wasn't
anymore.
great.
Not
anymore.
Beautiful.
I jinxed it.
Beautiful. I am so proud. Genuinely.
Wow.
Well done.
That's impressive.
So, if y equals 4, it's a horizontal line because it's every y coordinate where the y, or every coordinate where the y is 4. Locked out. And then when x equals 5, it's a vertical line. At 5. Does this make sense? This is just review? Okay. So, what is the slope of the line y equals 4?
No slope.
There is a slope, but how do we mathematically
Or,
define
sorry,
nothing?
0. slope.
0! Absolutely. The slope is 0.
So is the other one undefined?
Yeah.
The other one is undefined.
Oh,
M,
yeah.
undefined.
I get them mixed up.
Same.
So you just need to figure out whether or not y is changing. If it's going up and down, y is changing, and then it's undefined because the x isn't changing. So then you would have the change in y over 0, which is undefined.
Got a lot of that in the homework.
Yeah.
Was that
Yeah.
It was
supposed to?
easy.
Okay, good.
I liked it.
I got like 4 or
Okay.
5, I would say. There
Yeah.
So
same.
then 2, 3 should be good.
We good.
2, 4
Bless.
should be good.
I don't really.
Like,
I want to know when
My
the
brother
pizza's
teases like
coming.
that. I don't even know what to say.
How much more time?
You're like,
I don't know. It's 10:52.
Doesn't
say how much
It's
time
want
till
pizza.
pizza.
And now
Because
we go
it's-
into.
Can you check the time for the pizza? No,
5 minutes.
for the pizza. No, it hasn't.
We need pizza
Yeah.
time.
It's been like 7.
track my pizza?
It's been like 17
Wow.
minutes.
We'll like call the company
doubt it.
10 times.
Bake.
Just like, where are you?
Making.
How many minutes though?
It doesn't say. It says it's baking. Estimated delivery 11:04 to 11:14.
Okay. So before class is done, it's okay.
Yes. Okay. So direct variation. This is probably something new, unless there's a chance it's not, and that would be entirely dependent upon your Algebra 1 teachers.
What
So-
page?
This is on page 94.
Oh.
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 We're all like,
I
Ooh.
flipped exactly to 94.
Don't you love
So
it when that
proud of
happens?
myself.
that's impressive.
Yeah.
What's the date?
Today,
25th.
25th.
so
2017 as well.
when we're given direct variation, when we're talking about lines and the equation or the relationship in between the y and the x, remember that that relationship is defined by multiplication, and that is how we have our slope. So if we have y equals mx plus b, x and y are increasing or decreasing by a factor of m compared to each other. This makes sense? In order to get the y, we need to first multiply x by m, so that y is always
God bless you.
n times as big as x. That's okay? So, say we want to find out what y is. We have y equals 4x minus 3.
They're twins.
So, we want to find out what y is when x is 2. So, x equals 2 in this situation, and we have y. Can you see okay, Kirsten? And Isabel?
I can't really see. Okay, now.
No wonder you're not writing anything.
Okay. So y equals 4 times 2 minus 3. So to find out what y is going to be, we need to multiply that 2 by 4. And then we're going to get 8 minus 3, which is 5. And then to go higher than that, so we want to find out what y is when x is 3. So we have 4 times 3 minus 3. Well, this becomes 12, right? Minus 3, which is 9. Does that make sense?
Mm-hmm.
And then we've got when x is 4, y equals 4 times 4 minus 3. So 16 minus 3 is 13. Does that make sense?
Mm-hmm.
Okay. So for every 1 that I'm increasing my x's, 2 to 3 is 1, 3 to 4 is 1. How much are my y's increasing by? 4. So, y's are increasing at 4 times the rate of x.
Whoa.
Does this make sense? Cool. So, the only difference between your slope-intercept form, does anybody see where I put my eraser?
What?
The slope-intercept form, which is y equals mx plus b, and what we're going to talk about right now, direct variation, is that direct variation equations do not have a y-intercept. The y-intercept is just 0. So y equals k times x, where k is just some constant. The constant of variation. So from one point to the next, x and y will change, but k will not. And that should be expected, right? The slope doesn't change when you're talking about a line when from part of the line to the other part of the line. Then it wouldn't be a line. Cool? Cool. Cool. Okay. So, all we really need to find then is this K. So if we are told that bananas vary directly with acorns by a factor of 3, that means y equals 3x. Okay, so translating it step by step into math speak. Bananas, it's going to be y. Vary directly, that means they're both right here. The only difference between them is that there's this 3 here. That's the direct variation. It's going to be the multiplication. With acorns by a factor of 3. Make sense? So, if they tell you, a very classic example of this is if they say something like, when you are, let's see,
Eating pizza.
okay, eating pizza. So, the number of pepperoni slices varies directly with how large of a pizza it is, with like the area of the pizza. Okay? So, when you have 10 centimeters squared, it's a very small pizza, of pizza, you have 15 slices of pepperoni. Pep. Okay?
That's a lot of pepperoni on a pizza.
Yeah.
I only have like
Yeah.
That's like a tower.
Like completely.
Yeah.
Seriously. So, and then it says, how many pepperoni pieces or slices would you have on a pizza that is 30 centimeters squared? And then, how many pepperoni? They've already told you that they vary directly, so you already know that this relationship will fit into y equals kx. So, if this varies directly with this, that means this is our y. So y equals k times x. So when y is 10, x is 15. Make sense? We divide both sides by 15 to figure out what k is. And we get that k equals 2/3. So, when y is 30, we know our k value is 2/3, and that's what remains constant in the relationship. X and y can change, but k will always be 2/3 when we're talking about this pizza. Equals 2/3 x. We're looking for x, so we're going to solve by multiplying by the reciprocal. So these cancel out. When you multiply one side, you have to multiply by the other. 15, 45
That's a
equals
lot.
x. Does this make sense? Cool. What's even more fun is when we get into inverse variation, but that actually creates like a hyperbolic path. So we're going to wait until you guys learn about hyperbolic paths. Cool.
Oh boy.
Yeah. Okay, any
Everybody
questions about
sounds
direct
really
variation?
excited.
We are just blowing through chapter 2.
Pizza time we're on.
8 minutes.
Okay.
But you don't know if
Counting.
it's gonna be exactly 8 minutes.
Yeah, it
Probably
better
gonna like
be.
a good
So, by the way,
15.
somebody needs to go up front and wait for the pizza with the money.
I can do.
Wait, am I paying for the whole thing?
I'm not sure.
I got.
Okay. Okay.
I typically don't need my wallet. That's the
How
only
much
reason.
did you guys want to tip?
$4? What
$4.
do you think?
Okay.
I think that's
So-
pretty typical,
15%.
I'll
Yeah, I
give
thought it
14,
was
and
15.
you just give me the 10.
between 15 to 20.
Nice.
typical.
Secretly, just like takes the.
Okay.
Oh.
You better not.
5.
It's on its way.
Yay!
11:04 to 11:15. It's 11 o'clock.
Give me my pizza.
Should we look up how far Papa John's is
So
from
now
here?
we're going to talk
I really
about.
want that piece of it.
I'm hungry.
I can tell.
I didn't
everyone
eat
knows
breakfast.
Except
Oh.
for.
How are you not?
Wait, how
I
are we
never
gonna
did
do that though? Because then.
Me either.
Here's. Or,
I was
like,
like,
alright,
what
because then we'll
exactly-
both be
what
owed.
part of
You'll
it
be owed
is out
$10.
front? Is it over
I'll be
there?
outside.
7? No,
Because
because
maybe
you're
we
giving
should
10.
bring it in the side so we
Oh,
don't
yeah.
The guy
like,
will probably be
get in too much trouble.
What?
Let's like
I
take it
didn't
really
hear anything
Maybe
you
we
said.
should bring the pizza in this side door here, just so we can be.
smuggle the
sneaky.
pizza in.
There's
Here's
little
the money.
kids. There's little kids on their break there. I'm pregnant.
What class
What
requires
have you
that?
been
You're a
smoking
guy.
to look at and have your child look like that?
It's
Okay.
I'm gonna have a lot of ones.
So now we're going to talk
By the end of
about
this.
scatter plots.
Scatter
Scatter plots.
That one's fun.
I'm not a scatter plots.
Oh, plot. Oh.
Oh, I know
It's
about
a little
scatter
more-
plots.
What's
I'm
the
not a
drug
huge
you
fan
take
of
to
these
focus on
because
school?
this is where
Yeah, then that, because it's a
That
square
really
little
was good.
person.
A what?
As
Oh,
in,
yeah.
like, in the box person. Get it?
So, I'm not a huge fan of these because this is where math starts to emulate science and is
Oh, I'm doing chemistry.
Wait, but isn't that like
Right,
a really
chemistry.
good use of math?
that
That
is
test
an
was easy.
application of math, but I don't like science. Science is boring to me.
Really?
I like
Yeah.
science.
Seriously? I really like theory.
I didn't
So-
like
science.
biology.
Well, that would
I
be
like
more
this
what math
shit.
is. Math is
The
like a
part of the
giant
test,
theory
test.
of stuff
Yeah.
that we use to define things around us.
What page are we on?
We are on page 100.
Dun, da, da, da.
Wow, we reached 100 already.
We should
Look at
have
us
a
go.
pizza party.
Oh.
So,
We should do 340. 3.1.
starting with example 2,
3.14.
researchers
so
have
300
found that as you
14.
increase your walking speed, you also increase the length of your step. The table gives the average walking speeds and step lengths for several people. Approximate the best fitting line for the data. So, I'm going to also show you how to do this in the calculator to make this worthwhile.
Ooh.
Yay.
Calculator.
Calculator
I don't
is
have mine yet.
so much easier. You can probably do this on Desmos.
I love Desmos. It's fun.
Okay. So,
I haven't
we
used
have
it
our graph of our
It's so
data.
easy.
yet. Really?
So you
You don't even
have
have to work.
speed.
You guys get
That.
photo math. Get it.
Who wants
It's
to read
cheating.
these points
No.
out to me?
It's not.
Yes, it is.
It shows you the work.
Yeah,
How
that's
to do
cheating.
it.
Isabel,
Like how to do it.
Yes.
would you please read off the points to me?
What?
In example 2.
Okay.
So you're just going to say the speed and step and then speed step.
Speed 0.
So starting with 0.8.
0.8, 0.85, 0.9.
Oh wait, go to step first.
You go
Okay,
like
cool.
this.
Speed
So
step,
it's
speed step.
0.8, 0.5.
I know.
Then do it.
0.8, 0.5,
Okay.
0.85, 0.6,
Okay.
0.9.6, 1.3, 0.7, 1.4, 0.7, 1.6, 0.8, 1.75, 0.8.
Hang on one sec. I need to switch.
You sound like a professor right now.
1.9
I'm like dozing off.
and 0.9.
Oh, there's only one more?
That's
No,
it.
there's a bunch more.
Oh,
There's like a
okay.
whole
There's
other
like
row.
a whole nother row.
Yeah.
Okay, go ahead.
Okay. 2.15 and 0.9. And 2.5 and 1.0. 2.8 and 1.05. 3.0 and 1.15. 3.1
Why
and
can they not just say
1.25.
3?
3.3 and 1.15. 3.35 and 1.2. 3.4 and
One sec.
1.2.
1.2.
Sounds so done.
3.4.
3.4 and 1.2.
Is that the last one?
Yeah, that's it.
Okay, good. I'm not gonna know.
The
Okay.
exact tone of a professor.
So when it comes to graphing this stuff,
It's a lot of numbers.
so the first thing you need to do is identify like how you're going to make your little notches, what your scale is going to be for your graph. So we see that the speed ranges from 0.8 to 3.4. So our range of this data is however much is in between 0.8 and 3.4. So we're finding the difference between them. What math is that? Which operation uses differences? To find the difference between two numbers, you use subtraction. Yes. Okay, so we've got, let's see, 3.4 minus 0.8. That gives us 2.6 as our range. So we're going to start at 0. And then let's do 0.5, 1, 1.5, 2, 2.5, 3, and 3.5. Okay. And then our y values, which are going to be our steps, range from 0.5 to 1.2. So 0.5 to 1.2 is 0.7. So then, let's see. 12. Okay, so we've got 0.1, 0.2, 0.3, 0.4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so to plot our data, this is 0.8, 0.5. 0.8, 0.5. Who wants to plot this?
Me.
Yeah, here you
I
go.
love doing these.
Okay. I don't. This works out.
Really?
Yes.
Okay, where were you?
I did the first one.
Okay.
And then, do you want to go out front?
Mhm.
Do you want to go out front and wait for the pizza?
Sure.
Okay.
Okay.
Cool.
May I use the restroom?
Yes.
Can I?
No, you can't.
That's okay.
Am I
You physically cannot.
capable?
You are not.
Since May has mostly passed out of our vocabulary, our lexicon, and our usage, if we're using, actual descriptive linguistic theory in order to describe grammar, then saying can versus may is an unnecessary correction that assumes that the other person to whom was spoken does not understand basic systemic linguistic patterns. So, if
You
your
tell us
English
our
There you go.
if your English teacher says, "Can you?" then just say, "I'm so sorry that I thought that you would understand basic English."
I get in so much
Oh,
trouble.
my fault.
My mom would
She-
ground me.
Roasted.
Burn cream for that burn. My mom
Yeah.
would get pissed off.
Mom would be like, "Oh, good one. I'll use that."
And my dad was so proud of me. He was like, "That's my girl." And my mom would be like, "Don't ever do that again."
I got into a lot of trouble growing up from correcting my teachers. I remember when we were in 7th grade, we were reading Romeo and Juliet in class, and she told us that because Romeo and Juliet were both played by men, everything that we have like physically was just added in later, that they didn't actually like do much touching or anything like that. So I brought in my Cambridge University edition and said like, so this is the oldest known copy of the first folio that we have, and here you go. It says in the stage directions, they kiss.
That's
And
disgusting.
yeah, it is what it is. So,
Wait, 2 guys?
yeah.
Oh.
I'm sure it wasn't like the way that we kiss on screen today. Not we,
That's
including
like
me,
for
because
real
I didn't. But just like,
We.
or something. I don't know.
And
It just doesn't go over well usually when I correct my teachers. I had to learn appropriate times to do that.
it's like, okay, keep my mouth shut.
I mean, but as a teacher, I'm cool being corrected because I would much rather you guys learn the correct version. As long as you're actually
Right.
correcting me versus
Why
just
would a
disrupting.
teacher not like being corrected? It's like,
Because of the teacher.
Yeah.
Because they want to be right.
Wound your pride.
Who wants to do it?
Hello? Hi. So you're at the church?
Oh.
Yeah, just the main entrance is on the east side of the building. So when you come in from the street, you have to go around, and you should see like the main glass doors for the main entrance. Right, the playground is on the corner. Yes, and then just keep walking. You'll see the glass doors. And my student Isabel, she's Asian, is
Excellent.
looking for you. She's already waiting up there. Do you
There's
see her?
So many eggplants.
Awesome. Okay, thank you.
as in eggs on pizza.
Pizza's
Clearly you do not
coming.
Have you had
Okay,
egg on a hamburger?
so
No, but that's just a
Okay.
breakfast
Okay.
doesn't sound that bad.
Fried egg on
Okay.
a hamburger with like.
That's a breakfast sandwich.
Have you ever gone to Maui and had their burgers?
Hamburger.
okay.
No.
So back to scatterplots.
Okay.
Okay, so
Not yet.
here it is. So the example says after you plot these out.
Meat.
Yeah, it's beef. Wait,
So-
why is it called a hamburger when you put it's beef?
Because it's from Hamburger, Germany.
Makes sense.
Okay.
She does this.
It originated at one of their
You
meat
should
festivals.
just ask her.
Okay, So they didn't call it the hamburger when they first introduced it.
What was it?
I don't remember. Meat sandwich.
That makes
So-
sense.
That's what I called
Do
it
you
when
know-
I came to
and
America.
Sandwich is only called sandwich because the Earl of Sandwich invented it. That's why the
Oh,
restaurant
yeah.
at Downtown Disney is called the
Oh,
Earl of
that's what it's
Sandwich.
saying.
Because
When
his
I was-
servant thought of that as a solution to him not stopping playing cards in order to eat his dinner.
When I was younger, and I came to America when I was 8, my mom took me to In-N-Out, and I was
Hold
like,
up.
I do not like the hot meat sandwich. So it was a hot,
Okay.
like a,
So the problem says
Yeah,
to estimate the line of best fit. So we can draw it, but what we're going to do to estimate it.
hello!
Hey.
Oh, she's out there just looking at me so weirdly.
What?
The
Why are
lady?
you getting a pizza?
I was like,
well,
because
obviously
this is the
they're
coolest
both
math
for
class
me.
on campus.
Ever.
Yum.
All right. Oh, that
Not
looks
even
amazing.
Mrs. Strickland.
I love the
Who
crust.
wants to go to the bathroom and get some paper towels?
I'll do
Can we
it.
get a plate?
Okay. We have plates?
Not
Yeah,
even?
kitchen.
Uh-oh.
Oh, I don't know.
Can I grab
I
one?
kind of want to not draw attention to ourselves.
Or did they have a
Just
plastic?
in
Grab
case.
napkins from the bathroom.
I have
or
no idea.
towels or whatever. The paper towels, yeah, they're really thick.
They did not
Layer, like,
cut this
3.
properly.
Okay.
Well, they said.
Completely just not focusing on
Yeah, I noticed too.
This is
it. No!
Okay, well, I'm just going to show you guys how to do this. You can take notes if you want to, or you can keep eating pizza.
I'm eating.
So, here's our line of best fit. That's what it looks like. To actually define it, it's exactly the same as when you have just any old regular linear equation, except instead of picking exact points, you're just going to pick one of these points, or 2 of them, because that's how many points you need to define a line, and do it that way. So we're going to pick this one, why not, and this one.
What if you picked 2 of those points that are like right next to each other?
You probably don't want to do that for these types of situations when you have what's called discrete values, meaning that this, if it's a function, sorry, the olive's still there. If this is a function, then, blah, blah, blah. See how the line doesn't have any gaps in it?
Mhm.
The actual data values are only here, 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 and here. So if you pick points that are very close to each other like that, then you're not allowing for there to be any like approximation of the rest of the points. So I picked points that you don't have to pick like the first and the last. Just pick 2 that are roughly.
So you can pick them that are close, but it's not going to be accurate.
It might skew your answer. Yes. So like if we picked these 2,
Mhm.
the line of best fit, the slope would come out to be like 0.
Yeah.
So you want to
It'd be
pick
exactly
points that are
0.
like far enough apart to get an idea of the line. Okay. So, and if you are drawing the line yourself, you can just look and see on your paper which points it looks like the line intersects, and then pick those. So, x, because this was our speed, this was our step. So, x, y. So we have 0.85, 0.6, and 3.0, 1.15. So then change in y's. So we have 1.15 minus 0.6 over change in x's, 3.0 minus 0.85. So equals 0.55 over 2.15, which is so 55 over 215. Divide top and bottom by 5. Looking for the reduced fraction. We have 11 over 49. There you go. Cool. That's as hard as it gets.
So for the slope form,
Mm-hmm.
are they gonna tell us to use a certain one?
No.
Or okay.
I mean, like a
we don't
certain
have
set
that
of
kind
points.
like slope
Mhm.
intercept or whatever. 'Cause
Oh.
that's what you were doing right then, right? Like the. Like
Well, I was just finding the slope, and then you would
Yeah.
pick one of the 2 points that you used and use that slope and that
Okay.
point
So as
and
long as we
insert it to
find-
whatever one you want. Yes.
Okay.
Ha, ha, ha. Olives are so good. I just made the biggest plate of nachos with olives yesterday.
Oh.
I have
Yum.
Okay.
I like
Nachos are good.
I feel like if I keep going, you guys are going to have a ridiculous amount of homework.
No,
Don't
So
keep
we
going,
should probably just
let's just stop.
get started on the homework.
Let's do that.
Yeah?
please.
Wait, how much do
I
we
think
have
I have
left?
some stuff
How
that I
much
need.
time?
Like 20 minutes.
Yeah.
Hmm.
I mean,
Can we
like,
just-
I could keep going, but
Can we
there
just
are only,
digest our food?
there are only 3 sections left in Chapter 2. And then that's it. You're done
How
with
much?
Chapter 2.
So we're doing 2.5 and
We're
Yeah,
doing
'cause that'll be in 2 days
2.3,
anyway, so.
2.4, and 2.5 right now.
I like to
Right.
spend an entire another week on
then
it.
65.
Did we ever figure out how many of the chapters in this book we need to get through in just
All of
this
them.
semester?
All the
All of them?
we're going into pre-cal next semester.
Yeah, Chapter 12.
Hmm.
Woohoo! Chapter 14!
I was
I'm not-
excited. I'm like,
Wow.
oh,
We're
I
gonna
can
go through all of
get 7.
Okay, so you come up with your homework assignments. Normally I have this
Wait,
stuff
I'm
planned out in
confused.
advance, but
We're
I
doing
was
all of
really into the Raiders
Terrible.
game last night.
Wait.
Wait, what was the homework?
I'm writing them out.
Oh, no, we're not. We're not.
Right.
Everybody, we're fine.
Okay.
That's what my mom said.
Because there's 13
Oh my gosh, I
chapters.
just coughed
So
the
we
audio
went
back up.
through
Ew,
chapter 2
gross.
by week 3.
Oh my gosh.
And
Where
how
was
many
it,
weeks we
right?
have Before,
Fifteen.
like,
Thank goodness I'm
Semester.
recording this.
yeah. 16 weeks? in this-
16
Oh my
in
goodness.
each semester.
Yeah, okay, so
32.
Do you have your syllabus with you? It'll say.
I already know.
Mine's at home.
Yeah, that's so
I lost it.
Page.
Good job.
Oh, and we can be done with this.